Okay, so we discussed for the networking technologies. We did take a look at one of the few graphs on the mapping topology of the internet. They have a lot of edges, and there was few figures on analyzing the topology, the map of the internet in IP version 6, IP version 4, different part of the world having a different type of connections, ISP, especially connection between ISPs. ISP, again, internet service providers that you guys usually at the bottom layer of the entire internet architecture. So we did discuss some of that. And then we start discussing something called protocols, way of exchanging messages. And many people are familiar with the terms like TCP, IPs, and those things are actually promises between people, promises between processes to communicate each other, something called protocols. So we're going to take a look at one by one. And I think last class we discussed on something called data error detection and correction. I gave you one small example on when you try to sending out the bits in frames in the very low levels, whatever that coming in and out of that cable that we discussed, and then you might be able to implement something called error detection mechanism, something called checksums. What was the example that I gave you last class regarding the checksum? Error detection, yeah. If you send certain numbers, maybe you can add them all along with the addition value, along with the result of that addition, you send it to the receiver. Receiver checks it again. If the value at the end doesn't match what the sender sent, so the receiver can find out there was something wrong with the transmission in the between, right? 내가 뭐였죠, 예제? So you send 2, 4, 6, you add them all, 10. You send this and that through a bit pipe, 0, 1, 0, 1, 0, 1. Receiver on the other side can check whether, supposed to be 4, but this somehow got to 5. The value added up, 10, 7, 맞나? 이거 10도 아니네. 6, 4, 12. 미쳤구나. So if these values are not equal to each other, that you can guess. This side can know there's something wrong with the transmission itself. But this also has some potential problems like what? What if the value you send, this value got corrupted? Then you still have a same problem overall again. So that was the stuff that we discussed. We mentioned, this slide mentioned of the data link layer, but it's actually applied to all layers. Layering architecture, again, it will be covered more detail in the networking field, but the idea always almost similar to each other. And then go out to so when you actually try to send this bit numbers 0101, how do they send each other? What might be the nice way of exchanging message between the two? Sender, receiver, what might be the nicest way? 제일 편한 방법. Maybe receiver knows when the sender sending out the message. Also, sender knows when to send out the message. Means that sender knows when receiver is ready. If those two activities are synchronized, then you don't need to worry about anything else. But usually those things happening, you don't know when those things are happening. Also, if you try to share this link with a lot of other people, then it will be a problem. It will be a problem. 그죠? So sharing means that in your apartment or whatever building that you live in, you share an internet link with the other people. 무슨 얘기야? If you try to access certain servers at night, then it's really busy, slow. You feel slow. Your download ratio is slow. But if you try to access in the early in the morning, usually fast. It means that people try to someone else, P1, they all try to send the same packets that we saw last class. P2. And there's only one link to share, but so we have to find the order which one deliver first. Should I deliver this one first? Should I deliver this one first? Should I deliver this one first? Who make a decision? Nobody. In the internet architecture, there is, in the networking field, there is no one to make a decision on this part. So what do? What might be the natural way of solving this situation? 뭘까? 링크가 좀 푸지다. You let them be. So I don't know when this guy will send his packet. So just let them be. You send a packet and this link, this cable is free, then send it through. It will go through. If this one try to send their own packets, if this is empty, it will go through. What if both of them try to send the same packets at the same time? Solution, it's not a solution. The basic architecture is contention. If you find out that someone else also tried to send something else at the same time, both will be suspended. No one sends anything. Just wait. They will be blocked. These packets will not get through. What do they do? What might be the natural way of, if you implementing this algorithm to solve this contention problems, what would you do? What would be your pseudocode? 어떻게 하면 될까? Maybe I give a random timeout. This one, they tried, but this one find out someone else is using, or someone else is trying to send. So let's wait for 5 seconds and try it again after 5 seconds. But I say random. This one, when the same thing happens, this guy waits 3 seconds. So every time they wait for random seconds. And after 5 seconds, after 3 seconds, this one still on hold. This one can send because this one will be free. So problem is kind of solved. So you're giving a different waiting time for a users, entities, process. Contention based. That is a basic idea for implementing this. So these in your computer, these protocols implement this idea. This one is all software-based approach. At this moment, when you try to access your smartphone, LTE, Wi-Fi, whatever the connection is, it's actually happening now. Your cell phones try to get the connection. If there is someone else try to send the data at the same time, your cell phone is waiting until they get their free time. But you don't really notice that because the waiting time is very short, maybe a couple of microseconds, even nanoseconds. Okay. That's why you feel that you don't have any type of experience, any type of delays, but those things are actually happen. If too many people connected to a single line, if too many people try to call at the same time or try to make an internet connection through LTE, what is usually happening? 3G에 너무 사람 많이 모이면 어떻게 돼요? Slow, because you will be waiting more. Your probability of waiting will be increased. And everyone will have a different probability to when to send their data packages. So that's a basic idea. So it's a statistical based analysis. 어차피 통계예요. 확통. 여러분들 컴퓨터에서 패킷이 나가는 확률이 다 틀려요. 나가는 확률이. 어차피 확통이에요. So that's what it means to have a contention based. That's how your communication protocols are implemented in the data link layer. So what it means is whatever we like to use this cable, all of us, we are sharing the single cable at this moment. That's what's happening inside that cable. Okay. 패킷은 뭔지 다 기억나지? Last class we take a look at the Wireshark programs. Anybody tried that program at home? 혹시 다운로드 받아서 해본 사람? 아무도 없지. Because it wasn't an assignment. 숙제가 아니니까 아무도 없었겠지. Try that. It would be fun to look at those protocol formats. We're not covering those protocol formats in here, but if you're interested, you can certainly take a look at those protocol formats in short time. So that's a medium access protocol. Ethernet contention-based protocol is one of the ways to do it. Advantages, distributed, no master bottleneck. 이건 무슨 뜻일까? I already explained it, part of it. Distributed. Decision. No master bottleneck. 여기서 bottleneck이 뭐야? What is bottleneck? 잘 안 들려요. 누가 얘기했어요? 맞아요. How does the bottleneck look like? 술병. Bottleneck. More people try to get out, but this link, the cable is small. If there's no bottleneck, if your bottle look like this, then it will be no problem, right? So that's exactly what it means. And no master bottleneck means no one here to control which one go first. That's why it's a distributed architecture. 자율적으로 돌아가죠. Everyone is syncing their turn, making their turns without control of a single person. 누가 중간에서 명령해 주는 사람 없이 자기네들끼리 맞춰 가잖아. 5초 기다리고 3초 기다리고. 물론 동시에 5초 기다리는 경우도 있을 수 있겠죠. 확률적으로. 그렇더라도 길게 놓고 보면 결국에는 둘이 안 만나는 시간이 나오겠죠. 그렇죠? So that's why they call it as a distributed architecture and no master bottleneck. I know it's a bit difficult terminology to take for the scope of our course. It's just introductory to computer science. Again, it's more on the computer networks. So this is a brief diagram to explain what I just explained in this figure. So A sending, A, B try to send something. If this is time. If A try to send the time when B is not sending, no problem. So they don't interact each other. When A try to send, B also try to send, collision happening. 부딪히는 거야. No one is able to send anything this time, between this time. So both are waiting. There will be delay. So you can't send anything in that moment. After we implement the collision detection ways, if A and B try to send something at the same time, collision happening, no one is able to send. A waited for a while. Oh well, this one, 이건 B까지 있구나. B and C happened to collision. B waited some time and start again. Luckily, C is keep waiting. And then after B send, C's turn comes in. I mean, it could be another way around too. So that's a very basic idea for contention-based. 대부분 wireless, wired, it's all the same approaches. 다 이렇게 돼 있다고 보면 돼요. And there could be a lot of issues on this part, but I'm gonna skip. They also discuss your textbook, but discussing too much. I'm gonna skip some of the slide. But logical link control protocols, rules to detect errors, and ARQ algorithm. Don't worry about the ARQ algorithm. It's okay, don't worry about it. They mentioned something of acknowledgement and messages. I'm gonna make it easy. 누가 불렀어요? 누가 나 부른 것 같은데. I'm gonna make it a bit easy. Analogies on acknowledgement packet. It's still a packet. Don't worry about the link layer. I'm gonna explain this way. It's easier. The basic ideas for this. We usually draw this way. Sender. Receiver. You are both sender and receiver. When you actually try to type in naver.com in your web browser, you're both sending the data, receiving the data. What are you sending? It will come up in next few slides. What are you sending when you're typing on the web browser? Your message is asking something. Give me neighbor.com's object. Get me a neighbor.com image. Those messages are you also sending, receiving. You're also receiver. You receive the data that you requested from the web server. 달라 그러고 받죠? So both you are sending and receiver. But for the simplicity, I'm gonna make you as a sender because you request something. So this is what's actually happening. So it's a part of the process. You send some packets asking. Your message is asking something. Get me something. Get whatever. When the receiver receives that request, they usually do this. Okay. Okay message. They create a very short, small packet saying okay. That's acknowledgement. Okay means acknowledgement. We usually write it in ACK. So it's called acknowledgement packets. Acknowledgement가 뭐지? How do you translate that? 인식한 거죠. So you asked me something, I got your message. Same thing. It's keep repeating itself. Acknowledgement. So once you receive the message from receiver, you also act that too. Okay, I acknowledge your message, you send it to me. And then after this point, they keep, with the acknowledgement, they put a data, like your web page information object. They keep doing this over and over again. That's what it means to have acknowledgement messages or acknowledgement packets. To be more exact, there are different type of packets out there too. In terms of TCP, there is a packet like SYN packets, ACK packets, FIN packets. 여기는 안 나올 거예요. This is cases for TCP. SYN, just think of something you sent first time. I like to find out whether the neighbor.com server is running or dead. So I send the SYN packet first, SYN. If they're alive, they probably bring me back, send me a message back, acknowledgement I'm alive. So if to be more correctly, I should say SYN packet and then ACK, and then it goes like that. FIN, 이건 뭘까? Guess. FIN, finish. Let's finish talking. FIN packet, FIN messages. Then this one will say, okay, acknowledgement, done. You don't talk to the server anymore. So this typical way of introducing for communicating between the two. This is more of a TCP behavior. This one is for underlayer protocol, but don't worry about it. I just want you to know just very basic idea for SYN and ACK packets. 되게 쉽지? This is protocol. How to exchange a message between the two? These two knows each other. That's a protocol. What is a protocol? Human protocol of meeting somebody new. 사람 처음 만났을 때. What is a human protocol? 사람 처음 만났을 때 하는 게 뭐야? 악수, handshake. Handshake. That is a common protocol when you are introduced to someone else. Actually, TCP, they call it as handshake mechanism. Handshake mechanism. So that's a protocol to be. 손 내밀면 손 내미는 게 자연스럽게 받아들이죠. 그죠? 한쪽이 손 내밀었는데 반대쪽이 악수란 걸 해본 적이 없어. 그럼 가만히 있을 거 아니에요. 그럼 통신이 돼, 안 돼? 안 되죠. 똑같은 얘기예요. 똑같은 얘기예요. Protocol formats. 개념만 알아도 많이 도움이 될 겁니다. I'm gonna skip this. This is pretty much what I said. This slide. 너무 어려워. I'm gonna skip that slide as well. So the layering is something beyond this course, but just gonna mix it up. Everything I'm gonna mix it up. Just listen to me. It doesn't really matter. IP. When we call a IP, 그것도 뭐야? Internet Protocol. That's short for Internet Protocol. IP addresses look like what? 보기 뭐야? 166.140 something. This is Hanyang University IP address part. Whatever comes here, and you can guess your IP address. I probably can't even find out the IP address of this computer. 오늘 아침에 했는데 잊어버렸다. Anyway, it starts with 166.140 something something. So this is actually protocols, another protocol message too. So IP is a very popular protocol in networking protocol, network layer protocol between the two. So it's a transmission messages across the multiple node in the network. So this is like my phone number in the internet. Can I change my phone number in the internet? Yes, you can. Maybe at your home, every time you turn on your computer, you might have a different IP addresses. That is beyond something beyond this course. But usually, 이거는 166.140. This is given to Hanyang University for all over the world. It's not going to change unless Hanyang University give up this IP addresses. 이건 돈 주고 산다고 보면 돼요. 일반적으로. 우리 집에서 인터넷 쓰면 한 달에 얼마씩 내죠? 한 달에 얼마씩 내는지 혹시 알아요? 자취하는 사람 없어? 자취집에서 공짜로 주나? 한 2만 원? 2만 원 이렇게 주지? 2만 원? 3만 원? You're buying the IP addresses plus how much data that you can use. That's usually, hopefully that's a convention that you can think of. Requirement, standard for addressing all network node. If you try to find someone in the network, they will probably find them based on the IP addresses. Internet network layer, internet protocol, IP. IP 주소라고 그러죠? Internet protocol. Way of finding people in the network. Way of finding node in the network. So it's called address. The reason, but for the neighbor.com Hanyang University network, we don't know the IP addresses typically. Do you know the Hanyang University's main web page IP address? Do you usually memorize that IP address to type it in? No, right? You usually don't do that. Instead, what? You memorize www.hanyang.ac.kr. It's easier to memorize. Simply put, but so we're giving a name to this IP addresses. Giving a name to this to IP addresses. 뭐냐? 네이버닷컴을 잊어버렸다. 뭐 그것도 네이버닷컴 IP address도 뭐라? 124 뭐 이렇게 되나? 124점 뭐 아닐까? 200점인가? 하여튼. So every time you're typing in naver.com, somehow you will get to that IP addresses. So there must be something in the middle to translate those name into this IP addresses. Name into IP addresses. This is something called a domain name service, DNS service. Maybe I can show you in this computer, desktop, not my machine. Windows. 또 까먹었다. 어떻게 들어가야지? 아니다. 여기 있다. Do you usually see this menu? Anybody configure this menu every single day? Probably not, right? Anyway, this is one of the ways that you can take a look at your IP addresses. Internet Protocol version 4. 여기 딱 있죠? Internet 위에 거 클릭할게. Internet Protocol version 4, IP version 4. If I click that, click on the properties, this is IP address of this particular computer. 166.104.142.222. 이거 카메라에 찍혀도 되는지 모르겠다. 뭐 상관없습니다. 크게 상관없는데 어차피 다 막으니까 상관없는데. And then below they say something called 다음 DNS 서버 주소 사용. DNS server. We have to tell this computer this. If you want to find out certain IP addresses, then you have to ask these people, ask this computer. Simply look like this. Your computer. When you try to www.naver.com, you're talking to DNS server. This one gives you IP address of this naver.com server. Let's say I don't know the IP address 111.222.333.444. 444는 안 된다. So every single time you type something in your web browser or whatever, you actually asking this DNS server, give me the IP address of this particular website. Maybe I can look it up. 오, 왜 이래? 윈도우는 하도 안 해서 잊어버렸네. 커맨드. 이게 NS 문법이 아직도 있나? 나오네. So naver.com's IP address at this moment is 125 여러 개가 나오긴 하지만 one of them is 202.131.30.21. This is naver.com's IP addresses. So in the web browser, you can type up this IP addresses too. But we don't usually memorize naver.com's IP addresses. We usually memorize the names only. Right? But I'm just saying that there is a DNS or domain name service servers right here. They give you the answer of this IP every single time I ask. And sometimes this IP address may change. Maybe naver.com moved to another country. They moved to another country for whatever reasons. But their IP addresses and their IP address will change. But the name doesn't need to be changed. Aliases. 그죠? 약간 닉네임처럼. So often the users complain that I don't have a connection to the internet, usually a problem of DNS server. we usually use Hanyang University DNS server. Some people, they don't use the Hanyang University DNS server, they use something else. There are free DNS servers everywhere. 아까 거기에다가 한양대 DNS 서버 주소 말고 다른 주소 쓰면 그냥 써도 똑같이 돼요. So if you wanted to create any chaos, if you want to attack Hanyang University network, maybe you attack DNS server. DNS 서버를 죽여버려요. 그러면 다들 네이버.com 쳐도 못 들어가. 단 IP 주소를 알면 인터넷 할 수 있겠죠. 그죠? Normal users usually misunderstand. They don't understand the concept of DNS. So this is one of the example for protocols. So it's a DNS protocol. 여기 뭐가 들어갈까? How does this protocol look like? It's a very simple protocol. Maybe in the small packets, they write a naver.com. And empty. You send this packet to here, this server will read this, and the reply packet probably naver.com, that IP, 202, very simple protocol messages. 작겠죠, 패킷도? 뭐 몇 바이트나 되겠어. Well, it depends on the URL. 이거는 되게 작겠죠. 이건 몇 비트냐? 이건 몇 비트일까? 총 하면 32비트예요. 32비트. 이게 8비트씩. 8비트씩. 그래서 이런 주소 본 적 있어요? 256, 256, 333, 뭐 444 이런 주소 본 적 있어요? 안 돼요. 왜냐면 여기에 최대 거는 8비트니까 0000이 8개. 얼마야? 256이죠. 근데 왜 256이 안 돼? 그죠? 0부터 255니까. 그래서 나중에 뭐 또 바보같이 또 IP 주소 적은다 그러고 300점 뭐 이렇게 하지 마요. 가장 무식한 주 중에 하나예요. If you think about it, then we just discuss the IP addresses. So your computers. 웃지 마, 나 심각해요. Your computer has IP addresses now. IP addresses, but only one IP addresses. Maybe an IP address of A dot B dot C dot D. Okay. Thing is, in your program, in your computer, you're usually running a multiple programs to talk to someone else. Maybe you're running a BitTorrent. At the same time, you put a Skype. What else? 여러분들 제일 많이 쓰는 프로그램 뭐야? 아, 인터넷 브라우저, 인터넷 익스플로러. You doing something. 메신저 요즘에 잘 안 하지? 카카오톡 PC 버전 쓰는 사람. 많구나. 카카오 PC. At this moment, you're running a 1, 2, 3, 4 different programs. Everything is running at the same time. But you only have one IP addresses. 그죠? Then how can the others find if someone sends you a packet through your computer, but everyone using this IP addresses doing something different each other? How can you find out which one to go to? How do you know which packet belongs to which program? There is another question to be asked. So I know IP addresses. In order to find out which program if the packet comes in, where to go to, we give something called a port numbers. So I give you a port numbers, something like 스카이프를 잊어버렸다. BitTorrent, let's say number. Maybe 카카오톡 1012. Skype, I don't know, 7500. Internet Explorer, I don't care. Maybe 65. So along the IP, they can find your host through your IP numbers within the programs, within your computer. You find your program based on these port numbers. This is way to find something else. Usually referring to as a door and peephole approaches. 문이야, door. And this door has an IP address, one IP addresses. And within this door, there's a peephole like that. peephole이 뭐야? 이렇게 조그맣게 해갖고 누가 왔는지 안 왔는지 볼 수 있는 거. And there, I'm gonna number them. 1, 2, 3, 4, 5, 6. I have around 65 peepholes. If BitTorrent try to find me, they must be going through this peephole number 6881. BitTorrent only can go to here. Internet Explorer only can go to 6500. So we can distinguish a different process communications. 이거 다 프로그램이잖아. 프로그램 다 어디 있어? 메모리 안에 있죠. 그죠? 메모리 안에 요만하게 문이 다 저걸 요만한 문이 다 달린 거라고 보면 돼요. 여기는 큰 문. Door approaches. So if you wanted to find out some programs running which type of programs, so then you can find out what port numbers their program is open. If your computer is listening, if your computer is port 80 is open, it means you're running a web server. If you're opening a port number 22, it means that you're running a SSH, something remote control protocols. FTP 21, those things are all assigned by them. 그래서 해커들이 일반적으로 할 때 남의 컴퓨터에 해킹한다는 뜻이 뭐냐면 남의 컴퓨터에 들어가고 싶은 거 아니야? 그죠? 그럼 여기 65,000개 문 중에서 열려있는 문을 찾는 거예요. 그럼 어떻게 찾으면 돼? 아주 간단하게, 아주 멍청하게는 다 보내보면 되는 거예요. 65,000개 포트로 다 보내봐. IP 하나에 65,000개 포트로 다 보내봐. 패킷을 65,000개 보내봐. 그래서 문이 닫혀 있으면 들어갈 수가 없으니까 아무 응답이 없을 거고, 문이 열려 있으면 뭐 어쨌든 간에 열려 있다라고 연락이 오고, 그러면 열려 있는 대로 프로그램을 찾아서 들어가는 거예요. So if you scan, that's called something called scanning activities. So if you scan someone else's computer, then you can find out usually how many ports are there open. Sometimes you can find out their OS versions. Not sometimes. Sure, you can find out their OS versions. In fact, your computer all running this program, your computer, one of the programs in your computer controlling this port numbers. What is it? 지금 여러분들 거의 대부분 윈도우에 다 깔려 있는 포트 넘버 제어하는 프로그램 다 깔려 있어요. 그게 뭐야? 아는 사람? Firewall. 개인 방화벽 있지. 컴퓨터보다. That is controlling the port numbers. That is the first activity they do. 뭐 방화벽이 그것만, 요즘 방화벽은 그것만 하는 거 아니지만 가장 기본적인 게 방화벽이 문을 다 닫고 있는 거예요. 여러분들 윈도우에서 요즘에 새로운 프로그램 탁 클릭해갖고 설치하려고 그러면 이 프로그램이 방화벽에서 열리게 하겠습니까? 이렇게 물어보지 않아? 물어보죠. 거기서 예 선택하면 이 문이 여는 거예요. 이 문이 열리는 거예요. 아니면 다 닫혀 있어요. 보안 때문에. 옛날 OS들은 다 열어놨어. 다 열어놨어요. 기본적으로 다 열어놓고 닫힐 애들을 나중에 다 자기가 원하면 닫을 수 있어요. 요즘엔 반대예요. 다 닫아놓고 열릴 애들을 유저한테 물어봐. 물론 OS에서 기본적으로 열려야 될 애들이 있으니까 걔네들은 물어보지 않고 이미 열어놓고 똑같은 거죠. That approach is being used in the transport layer protocol, which is above the network. Network protocol IP 위에. IP 위에. TCP 얘기할 때 포트 넘버 나와요. So that is a port number, unique identifier for program. So unique identifier for process programs. That is a port number. Hopefully that gives you ideas for port numbers and transport layers. That clearly distinguish between IP and port numbers. 생각해보면 IP에 있는 게 있고 IP를 좀 보조하기 위해 위에 덧붙이는 게 포트 넘버. 이렇게 생각해도 무관해요. 그 위에 이제 올라가는 건 프로그램 관련된 프로토콜. 여러분들이 웃는 거 보니까 꽈시시 이미 CC가 많은가 보다. So this is what I just explained. If your port number 80 is open, then it's probably your web server is running. 80 말고 또 하나 있어요. There might be another port numbers too. 8080, 8080. 그죠? HTTPS, secure protocols. 암호 들어간 것들. Or domain name service, DNS service. The DNS servers must be open up a port number 42. So my computer will be asked the domain name service, DNS server, port number through the port number 42. And SMTP, if you need to send an email server must be opening port number 25. So those are the rules. And those things will release certain information about a servers through the network. TCP is using that. 이거 그냥 넘어가자. It's okay. 똑같은 얘기네. Application Layer Protocol도 똑같고 아까 얘기한 거랑 거의 달라요. 거의 비슷해요. Port number가 중요하니까 여기 옆에 보면 port numbers. 그죠? Well-known port numbers. Well-known port number는 뭘까? Because these programs are quite common. HTTP web browser is quite common. POP3 is quite common to read the emails. IMAP as well. DNS 서버는 다 있어야 되겠죠, 여러분들. DNS 클라이언트는 다 있어야 되겠죠, 여러분들 컴퓨터에. 그래서 포트 번호가 다 정해져 있어요, 사실은. 1024번 위쪽까지는 다 정해져 있어서 그 OS가 오퍼레이팅 시스템이 1024번 위에 포트 넘버는 여러분한테 안 물어봐요. 그러니까 이미 정해져 있어서 여러분이 쓸 수가 없어. 내가 프로그램 많이 짰어. 서버 프로그램을. 1024번 거 이후에는 쓸 수는 있지만 이렇게 대부분 그 OS랑 그 OS에서 자꾸 에러 비슷하게 나요. 쓰지 말라고. 1024번 위쪽 거는 마음대로 써도 돼요. 마음대로 써도 돼요. I'm gonna skip HTTP. It's a popular protocol in the application layer. 뭐 뻔한 얘기고. This what I explained already. If you type on the IP addresses, 실제로는 어떻게 되는 걸까? If you type in naver.com servers, if you want it to be correct, then this is what you have to actually type. HTTP protocol. 아이고. naver.com. 그죠? And I also need to say something about port numbers. To be more exact, this is what you should be typing to be more exact. naver.com 서버에 80번 프로그램으로 나를 연결해 주세요. 어떻게? HTTP 프로토콜을 이용해서. 근데 일반적으로 어떻게 해요? 이것만 쳐도 되죠? 이거 치는 순간 여기랑 여기는 자동으로 붙여줘요. 그렇게 다 브라우저에서 다 해주는 거예요. 해봐요. 이렇게 쳐도 다 들어가져요. 똑같은 얘기예요. 아까 뭐 get message 하는 거 있었죠? 왔다 갔다 하는 거. get messages, same thing. I think I already explained all this stuff. Anyways, 넘어가자 이거. 소셜 네트워크 아마 if we have some free time, hopefully at least one class, then I will show you something on the social network SNS modeling slide. This is not from our textbook. It's a bit difficult, but hopefully we will have some free time. Probably the last class of the course. 시간이 나면 아마 SNS 모델링 관련 것도 아마 가능하면 할 거예요. 시간이 나면. 여긴 다 아는 거다. 넘어갑시다. 일렉트릭 이커머스 이건 아마 여러분들 과목이 따로 있죠. 시간이 나면 하는데 이건 뭐 이건 뻔한 얘기 아니야? 일렉트릭 이커머스 뭐야? 그냥 이베이 아마존 얘기하는 거예요. 별거 없어요. 페이팔? 요즘도 페이팔 쓰나? 페이팔 쓰는 사람. 페이팔이 뭔지는 아는 사람. 우리나라에 잘 안 쓰죠. 페이팔 창업자가 떼돈이잖아, 그죠? 그 아저씨 이상한 벤처도 많이 해요. 그래서 그 벤처 회사 한국 지점도 한국에 있어요, 있기는. 나도 얘기만 들었는데 어디 있다 그러더라고. Anyway, brief history of the internet, blah blah blah. I'm gonna quickly say internet is from Army Network, DARPA. DARPA, so they call it as ARPANET. DARPA funded, simply put as Department of Defense, 미국 국방성. 70년대, 60년대, 70년대. 미국 국방성이 학교에다 돈을 줘서 대학교끼리 연결하는 네트워크를 한번 만들어 봐라. 그래서 만든 게 인터넷 시초예요. 알파넷이라고 해서. ARPANET. 원래 목적은 뭐였을까? 내가 얘기했나? 인터넷 원래 목적? 원래 목적은 왜 국방성이 저런 걸 했을까? 미국 전쟁하는 그런 디파트먼트에서. 우리나라 지금 국방부가 하는 건데 왜 했을까? 맞아요. 연락 많은데 그 전제가 하나 있었어요. 정확하게는 나도 책에서 읽은 내용이라. 당시에는 콜드워잖아. 냉전 중이잖아. 그래서 누가 핵 먼저 쓰면 다 죽는 거 아니야. 핵이 떨어졌을 때도 통신이 될 수 있는 구조를 원했대요. 인터넷은 분산 구조잖아. 한쪽이 끊어지면 다른 쪽으로 통해서 들어가고. 그런 거에 시초로 해서 원했다고 그러더라고요. 그래서 내가 먼저 핵을 맞아도 내 핵은 쏠 수 있게 보복은 해야 돼. 뭐 그런 식의 개념이 있었다고 그러더라고요. 그때 정확하게 그게 진실인지 아닌지 모르겠어요. 어쨌든 간에 인터넷의 시초 자체는 미국 국방성 네트워크가 맞습니다. 알파. Internet is simply put as a node. This is a Dijkstra algorithm, same thing. This is the graph that I wanted to apply algorithm to find the shortest path between this guy to this guy. Same thing. That's the very basic idea of something. Some of the slide that we skipped was called routing. Try to find a way from here to here. What is the shortest way? But this architecture, if some of the node is gone, some of the edges are gone, then it could find another path over here. That's more important. Something called redundancy. Redundancy. If this edge is removed, I'd be able to still go to that destination. Redundancy is the key part of the stuff. 뭐 똑같고 넘어가고 월드와이드 웹은 또 알고 그거 하나만 더 하고 가면 되겠다. First ever website is built by HTTP hypertext라고 그러죠? What is hypertext? Hypertext. Your web page are all consist of the hypertext. 그죠? 그죠, 맞아요. 링크예요, 링크. So if you click a hyperlink text, then you will go to another information source, 그죠? Another page. That is hypertext. Document containing link to the other document. As soon as you click a link, they open up sometimes you go to that website or they open up another window containing another document. Link. So this guy made first ever website. First ever website in human history is not a neighbor.com. This guy's website, personal website. 그렇죠? 이게 원래는 그 인터넷에 옛날 그 웹페이지 그대로 다시 복원해 놓은 게 있었는데 지금은 약간 다운이 된 것 같더라고요. 그래서 비슷하게 볼 수 있는 게 하나 있어서 찾아놨는데 뭐 이렇게 생겼대요. 라인 모드로 여기로 들어갔고요. 여기서 보면 this website in CERN 이거 유럽 물리학 뭐지 그 이번에 무슨 힉스 입자 발견했나 안 했나 했던 맨날 신문에 나오던 힉스 입자가 뭔지는 아니? 나도 몰라요. 하여튼 이렇게 뭐 이렇게 레이저 광속기 뭐 이렇게 하고 스위스에 어디 있죠? 그 선 원래 저분이 선에서 저 물리학 랩에서 일하시던 분이에요. 그래서 저기 원래 클릭하면 first 웹사이트 갈 수 있었는데 지금은 약간 다운이고 두 번째 first 웹사이트 제일 먼저 웹사이트 만들었을 때 라인 모드로 들어가서 보면 이렇게 생겼대요. 아, 잘 안 보이나? 그래서 클릭하면 오, 깜짝이야. 뭐 이렇게 해서 계속 클릭해서 들어가면 보여요. 그냥 옛날 하이텔 같은 느낌이 나죠. 별건 없어요. 그냥 간단한 소개 정도. 그렇대요. 외울 필요는 없어요. Tim Berners-Lee, he's professor at UCLA at this moment. Anyway, done. 다 했다. When, it's all connected. IP addresses, port numbers, you know the very basic stuff. So some of the stuff that I skipped, don't worry about it. If I skip those slides, then it will be not on the final exams. Okay. 내가 중간중간에 넘어간 슬라이드는 기말고사에 물어볼 가능성이 거의 없어요. 지로. 숙제에서 물어볼 수도 있겠지. 근데 간단한 거고 이미 어느 정도는 얘기를 했으니까. Okay? Any questions on this chapter? 질문. 없어요? 오케이. Let me go to the next chapter. 이거 보니까 갑자기 생각나네. 보안 막 관련 있는 사람들 일반적으로 뭐라고 얘기해요? 서버를 구축하면 가장 먼저 해야 될 게 뭐예요? 보안에 관심 있는 사람들은 아마 그런 얘기를 많이 해요. 가장 먼저 해야 될 게 내가 쓰지 않는 프로그램은 돌지 않게 해놔야 된다 이렇게 얘기해요. 다 죽여놓으라고. 그게 무슨 뜻이야? 똑같은 얘기야. 내가 쓰지 않는 프로그램이 돌지 않게 해놓는 거는 문을 닫아놓는 거예요. 그래야 그 확률을 줄이니까. 하여튼 조그만한 건딱지라도 있으면 글로 막 파고 들어와서 시스템을 죽이려고 그러니까. 그렇죠? 그런 뜻도 있어요. Okay, let's go to this new chapter. After studying this chapter, you will be able to describe the step to Steps to take increase of the security of the information on your computers and online. So we will discuss something about security. When you're discussing something about information security, 정보 보호, usually discussing two different stuff in two big pictures. One is for encryption, 암호. The other one is security in the internet, like things that you hear of, hackings, or making zombie machines, doing a DOS attacks. Do we all know what does it mean to have a DOS attack? DOS가 뭐지? DOS. 맨날 you hear this a lot from the news, 그죠? What does DOS stand for? DOS가 약자에 뭐예요, 약자요? 옛날 DOS 얘기하지 말고 DOS. Denial of service. You do something to these computers that their program will having a difficult time to provide the service they're originally built with. Denial of service. DDoS. 앞에 D 하나 더 붙이죠. DDoS. What does extra D stand for? Death? 과격한데? 좀 과격해요. 말이 죽인다는 거 진짜 죽이진 않아요. 그렇죠? Distributed. 분산화된. Distributed DOS. DDoS. Nowadays, pretty much every DOS is DDoS. So nowadays they call it DDoS. Everything. So explain how the passwords are encrypted and using hash functions on the many systems. Hash functions. 뭐야? 혹시 anybody watching those IT news or the news every night? There has been a big case lately on the something called heartbleed인가? Anybody heard that term? 뉴스에 계속 나오죠. Heartbleed. They say but usually news they don't talk about difficult stuff. They say it has a huge problem that hackers can hack into someone else's computer. There's something. The problem actually stands for hash function problems. So there is one protocol, the protocol that we discussed in the last chapter. One protocol is used for encryption only. So there is one protocol doing encryption. 암호화를 가능하게 하는 프로토콜이 있어요. So you can use it with some other protocols. That protocol uses certain called hash functions. 수학식이야 그냥. But it has some problems. So anybody can open up that hash key. Anybody can enter. Someone found that bug and they try to fix that bug. It's related to this, how your password is encrypted and how they are being hashed. So we're going to take a look at briefly on the idea of hash. Okay, hash will be introduced more in the data structure in the next term. Describe the cyber attacks, including viruses, worms, and Trojan horses, DDoS, DOS, phishing. 뭐 이런 건 여러분들이 더 잘 아니까. Phishing, smishing, they have a lot of new vocabularies that sometimes I don't even know what that means. Explain how they differ from each other. Encrypt and decrypt messages using a simple cipher, matrix-based block ciphers. So we're going to take a look at very easy way of encrypting your message. Very easy. It's not even a math problem, but we'll see how those things can be done throughout a very simple examples. And then we're going to just simply introduce some of the things that you can use in the internet, things that you can download and use when you're building your own softwares. If you try to implement the encryption ways, you don't have to come up with your own algorithms. There are standard algorithms that you can download and use. 암호화할 수 있는 알고리즘도 다 인증받아져 있는 게 있어요. 굳이 자기가 짜서 할 수도 없어. 아마 너무 어려워서. 뭐 예를 들면 우리 미국 같으면 니스트? 미국 정확한 번역 어떻게 보면 미국 국립 표준원 뭐 이런 데서 표준화된 암호화 알고리즘이 있어요. 그런 거 가져다 쓰면 돼요. 그러면 이제 패턴트 특허에 관련돼서도 크게 문제될 게 없고. Described over a process of the symmetric encryption algorithm such as the DES. It's one of those algorithms. Compare symmetric versus asymmetric. Symmetric versus asymmetric. Did we discuss asymmetric in the internet connections? 우리 한번 얘기한 것 같은데. What was the idea when we start discussing asymmetric routing in the internet? 그런 얘기 하지 않았나? If you try to send a data packet from Seoul to US, you can go through a Pacific Ocean line. But if you wanted to receive the same data from the same guy, you might be able to choose, well, in theory, you might be able to choose a path around the globe through the Europe to Seoul. 그런 얘기 하지 않았어요? 내가 보낼 때는 뭐 태평양 아래에 있는 해저 케이블을 미국에 보낼 수 있어도 받고 싶은 거는 거꾸로 이렇게 한 바퀴 유럽으로 돌아가지고 그러면 뭐라고 했어요? 어시메트릭이라고 했죠. 갔던 길을 다시 돌아오는 게 아니니까. 시메트릭이면 갔던 길을 똑같이 돌아오고. Same thing. Symmetric and asymmetric encryption. Maybe you need two things to encrypt your messages and decrypt your messages. Symmetric, maybe you only need one key to decrypt and encrypt the messages. We're going to take a look at the examples. Describe over a process of RSA algorithms, RSA encryption. 이거, I think, now I remember my first ever 수학 math assignment 1.1 when I was in first year. 내가 아마 1학년 1학기 첫 수업 첫 숙제가 RSA 알고리즘 손으로 풀어오는 거였던 것 같아요. 물론 뭔지도 모르고 인크립션이라는 것도 모르고 그냥 교수님이 풀어주는 거 똑같이 베껴서 했던 것 같은데 우리는 거기까지는 안 할 것 같아요. RSA 스킴도 너무 길어. 근데 여러분들은 고등학교 때 웬만큼 다 했어. 그게 달라요. 나는 고등학교 때 수학을 많이 안 가르쳐줬어. 그래가지고 대학교 가서 많이 가르쳐줬고 여러분들은 고등학교에서 되게 많이 수학을 배우고 와서 이름만 모른다 뿐이지 이미 다 했어. 뭐라고 그랬느냐. 매트릭스, 행렬 가지고 막 이상한 거 많이 했죠. 그거 다 적어요. 난 행렬이 뭔지도 모르고 들어갔어. 들어가니까 막 박스 그리고 맨날 막 이래. Explain why the web transmission protocol SSL, TLS use blah blah blah. 요즘에 문제되는 거 SSL. Heartbleed. 요즘 SSL이 뚫려가지고 어떻게 저쪽에 됐다 막 맨날 뉴스에 나오는 거. Explain the importance of considering computer security for network embedded systems. I don't think we're going to discuss that much. But anyways, let's take a look at it. What does it mean to have a information security? Keep information safe. Encryption might be the first approach. One of the easy examples that you can take a look, I think I mentioned a few times. 내가 삼성 녹스 얘기했나? 안 했어? 미쳤구나. Anybody has a Galaxy 3 or above? 갤럭시 폰 있는 사람, Android Galaxy. 없어? 갤럭시 쓰는 사람이 없어? 오, 왜 이렇게 근데 생각보다 많이 없네. 아이폰. 아이폰이 더 많구나. 삼성 계열 뭐 갤럭시나 삼성 계열 쓰는 사람 많죠? If you recently update your devices, then they probably install some program that you never know before. 삼성 녹스라는 프로그램이 깔렸을 거야. Whether you like it or not. 맞나? 녹스. You can check on your cell phone now if you wish. 한번 찾아봐요. 어디 숨겨져 있을 거야. 안 찾는 앱 디렉토리에 이렇게. 녹스라고, 삼성 녹스라고. 이렇게 방패같이 이렇게 돼 있을 텐데. 이렇게 돼 있나? 그럴 거야. 찾았어? 이게 없으면 업데이트 좀 해. 업데이트 좀 펌웨어 업그레이드 좀 하고 해. 그죠? 그냥 산 대로 그대로 쓰다가 버리지 말고. 찾은 사람? 이거 써봤어요? 있는지도 몰랐죠? 네, 맞아요. So it's a certain application by Samsung. If you enable this app, then you can have a choice to whether you can encrypt all the data in your phone. Means that you can encrypt your friends' phone numbers, your friends' names. So even if you lose your phone, your data cannot be revealed. Yeah. So they give you a choice for encryption part. Of course, it has other functionalities, but it's one of the features that you can start. 녹스 같은 거 왜 하려고 하는지 막 뉴스에 나왔었는데 왜 하려고 그런대요? 미국에 납품하려고. 미국 정부에서 쓰는 폰들은 지금까지는 아이폰이나 블랙베리. 블랙베리 BBM 써요? BBM은 안 쓰죠. 블랙베리 메신저는 안 쓰죠. BBM이라고 블랙베리 메신저 우리 카카오 쓰잖아. 카카오 같은 건 저번 시간에 얘기했지만 중간에 누가 마음만 먹으면 다 BBM 같은 블랙베리용 메신저는 기업용 메신저는 쓰는 메시지가 전부 다 보낼 때 다 암호화돼서 날아가요. 그래서 기본적으로는 그 보호가 많이 돼요. So Knox might be a good example. Keep your information safe. Control access to authorized people only. iPhone, those stuff. New iPhone 5, they provide the biometric sensors. They read your fingerprint to open up the phones. But is it secure? Yes and no. Right. So you usually discuss in two things: authentication and encryption, maybe part of it. Physical security: lock doors, maintain control of the devices. Online security: your web browser security. Are you clicking yes to every ActiveX messages that you see in your web browser? 특히 my wife. I gave my wife a small laptop a few years ago. 근데 I get it back after 1 year. It's full of new viruses. I never seen it before. 하도 뭐 이상한 걸 클릭을 하도 많이 하셔가지고. Only solution that I have after I get back my laptop was reinstall in Windows. 결국엔 다시 깔았어요. Are you doing it or not? Are you reading those messages carefully to when you're clicking yes to those ActiveX? Sometimes security is not about technology. Security is about the behavior studies. Whether you tell someone to follow certain rules. But people usually don't listen. So you have to make your system to be force the users to follow something. Like what? Easy example. A lot of websites, they ask you to change your password in difficult format. Otherwise, they don't let you change your password. 애플 웹사이트 로긴 아이디 만들고 패스워드 체인지 하려면 뭐 이렇게 내 평소에 쓰는 거 탁탁 해갖고 하면 특수 문자를 포함해 주십시오. 뭐 이런 거 나오잖아요. 그죠? 그런 식으로 시스템에서 유저한테 계속 요구하는 거예요. 어차피 그렇게 안 하면 사람들이 안 따르니까 그냥 1, 2, 3, 4 해놓고. So that's more important actually. How you can design your system to make people to follow your policies. So that's more important than the encryption techniques. 암호화 기술 뭐 이런 걸 다 떠나서 그런 게 더 중요해요. In fact, you're experiencing those type of forcing mechanisms every single day when you're doing web browsing. Anyway, I think I have to stop here today. 오늘 여기까지만 할게요. And any questions for today? 질문.